Hello everybody, welcome to my channel. Today we are going to do current electricity. Current is the rate of flow of charge across a cross section normal to the direction of flow of current. So current is I and charge is denoted by Q and time is T. So I is equal to Q upon T. It is a scalar quantity and its SI unit is ampere, which is denoted by A. So current is 1 ampere if the rate of flow of charge is 1 coulomb per second. If n electrons passes through cross section of conductor in the time t, then the total charge passed through the conductor is q as q, which is equal to n e. A current in a conductor is given as I is equal to q upon t, which is charge upon time, which is equal to ne upon t, which is same as q is equal to ne. Okay, so concept of proportion, uh, potential and potential differences. Okay, so the conductor with higher concentration of electron is said to be lower potential than the conductor with the lower concentration of the electron is said to be higher potential. The electrons flow from a body at a lower potential to higher potential. Okay, the electric current flows from body higher potential to lower potential, and this is called as conventional current. This direction is opposite to the direction of flow of electron, which is electronic current. So measurement of potential as work done per unit charge. The potential at a point is defined as the work done in bringing a unit positive charge from infinity to a point. So potential difference is equal to work done upon charge. So V potential is denoted as V, work done is W, and charge is Q. So V is equal to W upon Q. The potential difference between two point is said to be 1 if 1 if 1 volt if the work done in bringing 1 coulomb of charge from infinity to the point 1 joule. The potential difference between 2 point is equal to the work done in moving a unit positive charge from one point to other. So VA minus VB is equal to W upon Q. It is a scalar quantity and the it is its SI unit is volt, which is V. So now what is concept of resistance? Okay, so there is some obstruction in the current which flows through a conductor like a metal wire, and is obstruction is called electric resistance. So the current in the circuit flows due to the drift of electrons. The metal wire has been free electrons which move in a random manner. When the end of the wire are connected to a cell, the electron start moving from negative terminal to positive terminal. In this process, when they collide with the positive ion, due to this the speed of electron decreases, thus the metal offer resistance to the flow of electron because they collision. So you can see the diagram, metal wire, and this is positive ion, electrons bound, and now you can see. So now the resistance of a conductor depends on factor length of resistance. R, which is thickness, is directly proportional to the length and thickness of conductor. Resistance, which is R, which is inversely proportional to the area of cross section. Nature of conductor: the resistance, the conductor, the resistance depend on the material of the wire, as there is different concentration of different arrangement of atom in different material. Temperature of wire: higher the temperature of the wire, causing the iron it to vibrate more rapidly. As a result, the number of collision increases, hence the resistance increases. So now Ohm's law: the current flowing through a conductor is directly proportional to the proportional difference volt across its end, provided the temperature and the physical condition of the conductor remains the same. So this is the formula. R is constant for giving a metallic wire at a given temperature, and this constant is named as resistance. The SI unit of is ohm, which is denoted by the symbol ohm, as you can see. If we plot the graph for the conductor, then it shows, so current A and potential difference V, you can see the slope of the graph is reciprocal of the resistance of the conductor slope 1 upon V, which is equal delta 1 upon delta V, which is equal to 1 upon resistance of the conductor. Conductor is defined as the reciprocal of resistance. So conductance is equal to 1 upon resistance. Okay, so now we will go ohmic and non-ohmic resistor. Ohmic resistor, the conductor which obey ohm laws, are called as ohmic resistor or linear resistor. Okay, so for such resistor, a graph is plotted for the potential difference V against the current I is a straight line, and the value of R remains same irrespectively to the value of V or I. Non-ohmic law, the conductor which do not obey ohm law are called non-ohmic resistors or non-linear resist resistance resistances. So for these devices, the graph plot for potential difference V against the current is not straight line, but it is curve, you can see over there. So now superconductor. A superconductor is a substance of zero resistance or infinite conductance at very low temperature. The superconductor can be very useful provided it is possible to obtain them at a room temperature. The size of the computers could also be reduced to a few certain 2 centimeters, and the power lines could be then made as thin as a single cable. Now a specific resistance or resistivity. So the resistance of the wire depends on the following factor: directly proportional to the length L of the wire, uh, inversely proportional to the area of cross section of the wire, nature of the material of the wire. So R is inversely proportional to cross section of the wire, and hence the P, I will say that P, okay, it's something known as also. Okay, so P is the constant of proportionality, and it is called the elective resistance or a specific resistance of the material of the wire. So now the respect the resistivity will be given as P is equal to Ra upon I. Resistivity is the resistance of the wire that material of unit length and the unit area of cross section. It is SI unit of ohm meter, which is ohm. Conductivity, the reciprocal of resistance, is called conductivity. It is represented by the symbol. The SI unit of ohm to the power minus 1 meter to the minus 1, or semi men meter to the power minus 1. Okay, so now choice of material wire. The choice of material wire is the purpose which is wire is to be used. The wire which are used for the electrical connection for the power transmission should be posed negligible resistance. The resistance wire or the standard resistor are made by the material such as you can see. Okay, it's respectively it's quite larger than the effects of the change in temperature on their resistance is negligible. So now we will go with the electromotive force, terminal voltage, or internal resistance of a cell. So when no current is drawn from the cell, when the cell is an open circuit, the potential difference between the terminal of the cell is called as electromotive force, EMF. The EMF of the cell is denoted by the symbol epsilon. It is unit its unit is volt. Okay, so factor affecting EMF of a cell: the material of electrodes, then shape of the electrodes, distance between the electrons, the amount of electrodes. So now the terminal voltage of cell: when the voltage is drawn out from the cell when the cell is closer to a circuit, the potential difference between the electrodes of the cell and is called terminal voltage. So now we will do internal resistance. Okay, so what is internal resistance? When a current is drawn out from the cell, it flows from anode to cathode in the external circuit, and from the cathode to anode inside a cell through the electrode, so the maintaining a continuous flow. So that's known as internal resistance of the cell. Now relation is, you can see the relation. So now factor affecting the internal resistance of the cell. The internal resistance of the cells depends on the following factors: surface area of the electrodes, the distance between the electrodes, nature of the concentration of the electrolytes, and then temperature of electrolytes. So now this is the resistor in the series, as you can see. So the current in the series remains the same across all the resistors. The resistance the resultant resistance of a circuit is given as R is equal to R1 plus R2 plus R3. Here R3, here R is as a resultant resistance. The resultance resistance is greater than all the resistance. Now we will do the resistor in parallel. So the potential difference in the parallel remains the same across the resistors. The resultant resistance of a circuit of the circuit is given as 1 upon R. P is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Here Rp is resultant resistance. The resultance resistance is lesser than all the resistance. So yeah, that's up for today's video. So please like, share and subscribe. Thank you.